Okay, let's look at example 2 here. Here it says even if the domain and codomain are the same, the map the matrix represents depends on the bases we use or we choose. So if H is this matrix here and we choose B1 equal to D1 is this set of vectors, and then B2 is equal to D2, and we have this set of vectors, except we switched the order. Remember, order matters with bases. So now what we're going to do is we're going to show two different functions using H1 and H2. So in H1, the mapping from R2 to R2 represented by H with respect to B1 and D1 maps C1, C2 this way. So we go from C1, C2 is equal to C1, C2 with respect to B1, and then it's mapped to C1, comma 0, which again is equal to C1, 0. Okay, so notice this is a projection onto the x-axis. Okay, now let's look at H2. H2 is also a mapping from R2 to R2 represented by H. Now with respect to the bases B2 and D2, this is the map that's given here. So we end up with, we start with C1, C2 again, but this time now it's C2, C1, so it's flipped, and then as we map it goes C2 to 0, which is equal to 0, C2. So this is a projection onto the y-axis. So they're different functions based on the basis we use. All right. So this result means that when convenient, we can work solely with matrices, just doing the computations without having to worry whether the matrix of interest represents a linear map on some pair of spaces. Now, when we are working with a matrix, but we do not have particular spaces or bases in mind, then we could take the domain and codomain to be Rn and Rm with the standard bases. And this is convenient because with the standard bases, vector representation is transparent. The representation of V, the vector V is just V itself. And in this case, the column space of the matrix equals the range of the map, and consequently, the column space of H is often denoted by R sub H. Okay? So just be aware of that, okay, as we go on. And we're going to introduce another theorem. Now, given a matrix, to come up with an associated map, we could choose among many domain and codomain spaces and many bases for those. So a matrix can represent many maps. So keep that in mind. All right, so we're going to introduce another theorem next.